everyone, welcome back to my channel. So today we are going to talk about TCP socket, TCP, how to communicate with TCP socket from one machine to another machine, from one place to another. What is the use cases? How to implement this in C or C++. Okay, so today that's what we are going to do on this tutorial. On this tutorial, basically, we'll write down two things. One, TCP server, where there will be a server which will receive connection from TCP client. So I guess before that, first we should go through a little bit of details. I guess everyone is new on the TCP connection. I have been working with this network telecommunication for around like 12 years now. So I have a little bit of experience on how those things works, how um, everything needs to be implemented so that people can really use it. Okay. I specifically have experience working with uh, um, as, as a the company where I have been working. This company has a huge line of product where we have been delivering those products many giant clients such as Google, Microsoft, Intel, Telecom, Polycom, many other clients. So I have been working in this company for 12 years now, and my all of my work is basically related to network stack. Uh, so I say network stack, but it's not like physical layer, basically the application layer. But on the network layer, we have been using this POSIX sockets in places when we use the Linux. And if we use like Windows, we are using WinShock socket. And for um, iOS, we have been using this NS socket, and for Android, we are using the same usual POSIX sockets in using the NDK, the native layer. Every one of you guys know like what is NDK is and how this thing works. So basically, that's my work so far. Uh, Now I am planning to at least give the prospective people who wants to work with the network communication, network protocols, some basics, how those things needs to be done. You guys probably see in my university life, from my university life, I was really interested in this uh, kind of this network telecommunication thingy. And when I was in my university, in my third year, I created this video conferencing project using Java and JMF. It is available on the GitHub. Probably you guys are using it. You guys are getting some benefit from these projects, I hope. I also created one C++ uh, client server chat client application where we have a server and then we have this client using the WinShock and MFC in Windows. So we have created a graphical user interface using MFC, and then the background on the back end, the socket was in WinShock, and we basically uses the WinShock socket. We created server, we created client, so and we have this client server chat client application. This is also available in GitHub. You guys can use it, and is also available in my YouTube video. So that's the background. My what I have been doing and why I am here to give you a little bit of tutorial so that you guys can get benefited from my experience. So first of all, what we'll do first we'll go through like you know this how in a network communications, there are like as you guys know, there are like basically two types of communication, right? Two types of connection. Okay, so there are two connection types. One is called UDP, another one is called TCP, and there is TLS, which is basically uh, an application layer security over TCP, so it's called TLS. Okay, and then nowadays there is like DTLS, okay, which is basically UDP over UDP. There is an encryption layer which kind of works as a TLS, so they call this DTLS, datagram TLS. um, and there is another kind of, which is an optional connection type, kind of SCTP, which is kind of like TCP. Okay, it's a TCP really, but you will see. So first, today's tutorial will basically go through TCP. So TCP is basically connection oriented. That means there is a dedicated connection from one endpoint to another when we think about TCP. So what is if I give you an idea, in general, what is TCP is, um, think about it, it's kind of like that. You have a rope, one end somebody is basically is on the one end and another person is basically on the other end. So it's a dedicated connection which is kind of like TCP. In case of UDP, it is different. So UDP is basically like, think about it, it's a Bluetooth. There is no connection, nothing else. You basically send the data will go there to the other side, may not go there. Okay, so it's kind of like, yes, there is a connection from this side to other side. Okay, okay, I'll give you this way. So in case of TCP, when you have a rope, right? This in this side there is a rope, and one end of the rope is in my hand, other end of the rope is the other. So whenever I send something from this end of the rope, other guys receive it. Think about it as a pipe. So on the one side of the pipe, when I send some water, the other side basically receive it, whatever it is, and then he sends me a message saying that okay, I received it. This is basically TCP. In place of UDP, okay, I send something. Let's say other guys receive it or not, he will not send me any notification. So which is basically UDP. So it is basically connection less. We call it connection less. There is a connection, but the idea is that it is not like guaranteed that it will be delivered or whatever. Okay, so that is UDP, and um, TLS is basically like there is another application layer security where it's a dedicated TCP connection, but when we send the data, we encrypt the data. We don't really encrypt data. We encrypt this connection layer and also the data. So as a result, the data that are going from one side to the another, nobody can see it. So it is not visible to human eyes. And to encrypt the data, we use like kind of a certificate. So like those are the certificate you see on the HTTPS on the website. Okay. So like those certificates are used to encrypt the channel, the connection. Anyway, so that's that. So today's tutorial is basically on TCP. I gave you the details about the connection type, what kind of connection type is there. So let's get started with the TCP. Uh, First, we'll go through the TCP server application. Okay, so if we finish this thing successfully, then you'll be able to create uh, various kind of chat application, even video conferencing, video call, many other things. Okay, so this is just a basic part, basic start, but it will give you an opportunity to write huge stuff. Okay, so let's get started. So let me create um, a file. or class or whatever, TCP server dot cpp. Okay, and I'll be creating this one where I'll be creating this one in my desktop and then TCP. So I created this folder. We create file. All right. So this file is created. Now what we'll do? We need to add some. So it's a basic implementation. We'll go from here. So initial. So on the basic implementation, first you need to include the header. So basic header is stdio, which is will be used to take input, whatever or printing input. Then we put the library stdlib dot h for the libraries if you use math or whatever, and then you use unistd.h that is also required for your TCP socket connection thing. Then we'll take this error printing header, so that we'll be using if there is any error or whatever. And then obviously the string.h for any kind of your string manipulation. And then we'll have these types. So these are the system types, and then we'll take those are basically the headers from the project socket. So these headers are required basically when you use the project sockets and their structure or whatever variable or whatever we need for creating this our client or server. And there you can see I have included this c/socket.h. This is basically a header file from socket project socket. So it's available on in the system of the machine system directory. So include net inet that in dot a. So this is required for your in address structure where you will put the IP address structure, hostname, or everything. Okay, so create a main function first. This will be your entry to the program. And then obviously if you write down as int rather than void, then you need to put a return 0. Then we do int socket. Okay, this is the socket where our TCP socket will be. This is basically the server socket. Okay, this is the server socket where our server socket will be. Okay, the third is server will have a socket and client will also have a socket. Um, so this server socket or current socket is basically the ID which we use to communicate with. So let's do this one. Okay, and then we are using a C program, right? It's not a C++, so it's basically a C program. So we'll try to write everything in C order. Okay, so will create two array for sending and receiving data in TCP. So let's write down like character send, let's say 100. Okay, and then character uh, snd character RCB. Okay, so we'll send and receive using that one. Okay, and then what do we need? We need the, as I said, we need the address, server address and client address, because we will receive the connection and we will also um, try to get the idea what IP address is connected with the server. This is a very important thing you need to know, because you want to map that IP address with your FD, and whenever you do this messaging or whatever, you need to know the IP address if you want to send back the results. Okay, or what about the response? Like for example, the user sends you a hi. Okay, and server receives the hi. Server needs to send out something back. What it will use? It will certainly use the FD where it receives the connection, but still he need to know the IP address if you want to show. Like okay, this data came from this specific IP address, right? So we'll have this socket. We'll have this structure sock address. Okay, this as I said, right? Okay, sock address in. Okay, so it's an address, sock address in. So one is like server address, DDR. Another one is like client, DDR. Okay, done. Then we create basically the socket. Okay, so as I declared the socket, I will create the socket now. Let's do it a little bit smartly. Okay, so let's declare it here in sock. Okay, sock, and then we create. This is a socket function from the sys.socket.h. Okay, so socket, we use the socket function to create a TCP socket. So AF inet. Okay, and then the sock stream. Okay, sock stream mean it's an TCP socket. If it was like UDP, then it would have been sock dgram. Okay, and then we will now we'll create our server address. Okay, there is a server address and this is the client address, right? So we'll create our server address. So for creating the server address, we need to initialize the server address structure. Okay, so server address dot scene family. That means as IP family. The IP family is basically inet, F inet. Okay, so it's an IPv4 address. Okay, it is not IPv6. So it's an inet. And then second one is server address dot scene underscore port. Okay, so what is the port we'll use for our communication? So if you want to put a port, you need to convert the port to host to network byte order. Okay, so there is a function called h2ns, and then using this function you convert the host byte to network byte. Okay, and then as I need to this server address, and then uh, server address dot scene ddr ddr dot uh, s underscore addr. Okay, with that we'll put the IP address. You can put the IP address anything, but for the sake of this implementation, I am putting in addr underscore any. Okay, so what it will do, it will get the IP address of this system, this machine. Okay, whatever the IP address it will take the IP address of this system. Okay, and you can also specify the IP address like in string character, right? Okay, here like this if you want. Okay, in place of in addressing. Okay, but for now I'm using in address any. It will take whatever IP address in the system and map it with its uh, host address. Okay, now I what I need to do, I need to set the IP. Now we need to specify okay how many. Uh, Now what we need to do, we need to bind the socket. Okay, so we'll bind. What we are doing, we are basically binding the socket with this IP address and port. Okay, So in addressing is basically the IP, the local host or whatever. The IP local host is basically this one. Okay, okay. So this is can be that one, or okay, whatever IP address available of the system, it will get this one if you put in address any. Okay, so then now we created this socket, right? Sock stream. When you put the 0, it will basically take any socket available. Okay, so it will take the any socket available from the system, and then what we do, we bind it. Okay, to bind the socket, there's a bind API, take bind. We are basically binding the socket with this IP port. Okay, so we took the socket and then we uh, convert struct sock in address in pointer reference of server address. Okay, and so this whole server address, we basically took it the reference of this references value for the bind and mapped it with the bind it with the socket. Okay, and this is the third param, size of struct sock address. Okay, and so this is basically the bind operation. There will be like the binding of the socket with the IP host IP. Okay, so binding done, and then our server should listen, right? Because this is a server, right? So server always listen, and the client basically connect to the listen port, right? So here the server is listening. So how many socket for the server should listen at a time? So 5. Okay, this is basically sock, this socket, and the 5. So on this socket, we can have at most 5 connection at a time. Right? And then what we do? So it will be like, as I said, it's a basic implementation, right? So we create a while loop, okay, and what we do, we when it's a while loop, right? So there is a while loop, okay. On the while loop, what will have a will accept connection, okay. So how will accept connection? Very simple. So int client sock. So first one was the server sock, now is the client sock. So client sock is basically where we'll accept the connect after accepting the connection on this specific FD, it will return you an FD. If we return you an ID, so this is called client socket. Okay, so accept will accept connection on this specific socket, um, and then there is the server sock. Let me rephrase it so it will be easier for everyone. Server sock. Okay, so I should do this server sock, server sock. Okay, so on server sock we are accepting connection. So server sock, comma, what the same thing that we have done here. Okay, so server sock, the same thing, just only different. What is the only difference? Only difference is it will be client address, because you are accepting connection. Here you basically binded uh, the server address with the server socket. Here what you are doing, you are accepting connection on the server socket and putting it in the client address, and in return you are returning a client FD or client socket. Okay, so and obviously the size of the same thing. Okay, exact same thing, exact same thing. All right, size of struct sock address in. Okay, now your client accept is done. Okay, when there is a successful accept, right, so we'll print it. That's the idea. When after upon receiving a connection, printf um, what will print? Received a connection from percentage s comma percentage d. So what we are going to do, we are going to uh, print the IP address using this function inet n2a network byte order to host client address dot scene address. This is what the IP address is for of the client, and then n2h is network to host byte order uh, port client address dot scene port. Okay, so there will be, if a connection arrive, it will be like printed that connection arrive. Okay, so now let's do one important thing. Okay, um, we'll do very like basic thing as I said. Okay, so what we'll do, when a connection arrive, when somebody connect to our server on this specific 5000 port, we'll print it from where the connection came in, on which port the connection is came in, and then we'll send out the response. Okay, like welcome to the server. Okay, okay, I don't know like will it build it or not. Let's try it out. So new terminal, and I think it should, this is so strange. Okay, so this should be, I think, desktop TCP, right? TCP. So we are back again uh, here. So we'll start building it again. So we need to compile it and see. I'm using a Mac. Usually I use Linux machine. So it is my Mac. So it might generate some error. Let's see. Probably, as you can see, this one fails for two things. Okay, so here it is complaining. Okay, so let me save it. It requires socket address, so I was putting socket address in. Socket address in will not work. Mm, so only socket address will work. Okay, so that is good. Let's convert them to socket address. Okay, and now let's build. Okay, so there is just only Well, we'll just disable this one just to check, uh, if you guys don't mind. So here, this one is basically complaining that we are converting uh, server address.syn port is not available, blah 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 blah. Okay, that is true because this server address is required to be a syn address. Okay, but well, you need to do this way smartly. So in is fine, this one is fine. You just convert it. Okay, all right. Now this one should work. Okay. So the only error it shows you the asset. Here no matching function for asset because uh, the candidate accept is asking for int, okay, then socket address, then socket len. Okay, here we are basically putting the struct size, right? So it is asking for socket len. Okay, so what we can do, we will do an interesting thing. Okay, so let's just, that's how you do things. So we just to see like how I'm doing one by one. I'm changing those codes, make it workable, usable, reusable, or whatever. Okay. So um, well, I will make it work. That's my uh, so here we'll put in socket len t, right? So let's just not in bind in asset and asset address of scene size. Just give me a moment, I'll give you the idea what is scene size. So int scene size, scene size equals to size of struct sub address in. Alright, and let's try it out again one more time. Okay, it's still giving me error. Why? T. Okay, so sub argument is socket len t. Uh, okay, I will do this. Just I will do very simple thing. Socket len, socket len, socket len underscore t scene size. Okay, so just here. Okay, so you need to put a reference. Just put the reference. It should do. All right. So sock len t instead of okay. So it built successfully. You can see. Let me clear it for you. So here, okay, no issue. And there you can see the server. I'll run the server. Okay, so it's basically running. Anyway, now I need to print it. So I'll print it. Printf receive connection in2a whatever. Let's see does it build or not. Okay, so it builds, and then we do run server. Okay, so server is running. Now the server part is done. Okay, now what we'll do, well, there's still an error. Why it is an error? Because inet n2a is unrecognizable. Okay, uh, so look like a recent time inet n2a is been uh, changed. It is supposed to be available UNISTD, UNISTD, but look like it is not available. So we'll check it later on. For now, I'll figure it out. I think it is probably available in ARPA in init. Let me try. Include ARPA slash inet.h. Hopefully. It has been very long, like I started. Yes, fantastic. So it is basically available in ARPANET. Alright. So this is nothing, it's just like ARPANET uh, header, the library, where inet has this init function where it's convert the network bytes to alphanumeric order, alphabetical order. Okay, so that's that. Now our server is ready. Now I'll write a client. Okay, let's do new text file. Okay, and here we go. We will basically take all of the same header. So let's just copy it. Okay, and then let's create a main function. Okay, so we created a main function, and then there is a return 0. All right, then here what we'll do, we'll basically copy everything, whatever, because we'll reuse it, right? So I don't want to write down, I don't want to write down all of those things. I just want to copy it and then put it in there and reuse it. All right, if you don't mind. So first of all, let me get some tea. All right, so here what we will do in our main function, we'll basically write down So okay, so we are basically creating a client. The first one was the server. So we'll create this as a client header. So TCP client. Okay, dot CPP. Okay. I mean, you can write down C. It's not a CPP, so you can write down dot C. But it's just my habit, so I put it dot CPP. So we already finished TCP server. Now we are on TCP client. Okay. Uh, Now I created this int main function. So what we'll do, we'll create exact same way. We need to create a socket, int socket, but we'll not need to bind it because you need to do binding on the server. What you did, you created the socket, right? We'll need to create the same socket. Socket required. Socket is mandatory. You need to create the socket int socket. Okay, so we'll create the socket for sure. But before that, let's do to snd send. Okay, this is send int rcb receive. Okay, so our send and receive buffer that we are planning to use, we don't know, and then we'll copy it. Let's do it. I create here. I really need this just only server address. I don't need client address because I will connect with the server IP, right? So I need the server address, server structure for server variable, and then I need the host structure host net hostent hostent really hostent. There is a hostent variable, hostent variable star host. Okay, so using this host, I will try to get the IP address. Okay, the server IP address. I will convert the server IP address to host byte. Okay, the server IP address. Why you need the server IP address? Because this TCP server, this specific TCP server running on this IP address, right in on JSRG on this machine. On this machine IP address, and port is 5000, which is open. And here, so I need the on the client side. From the client, you need the IP address of the server where you will connect. But the IP address is in character, like string character array, right? So you need to convert it to host to network order. So we call it hostent. Okay, so we'll convert the string IP address, uh, character IP address, string IP address to network byte. So that's why we have this host. Okay, so host equals to get host by name. All right, and here on the get host by name, you put the, for example, the local IP address. As I said, local host. Well, this is the local host where my server is running. You can put like the real IP address if you want, but it's on the same machine, so I'm basically using the host IP address. I'll show it to you later for sure. So no worry. Um, then what we do? We create the socket as I mentioned before. So here it was the server socket, right? So we'll create this one is basically your client socket, right? So this is the client socket. This class is for client, so this will be a client socket. So we created the client socket, all right. And then another thing. Then the next thing is the exactly same. Now we need this server IP address. Sorry, server family port whatever. Okay. So it's an IPv4 address. So SYN family is AF INET. If it is like an IPv6 address, then you put AF INET v6. Okay. So we'll go there later on in any of our next tutorial. Okay. Uh, about the IPv6 addresses. Okay. So what we'll do here. Here, what we will do. So here the server address family, we put the server address family. Server port is 5000 because the 5000 port is where the server is listening, and there we'll connect. And then we also need the server address. Now, on this server code, we put it in address any. That means where this code will run, it will take the IP address of that system. So in address any. And here we need to put the IP address itself of the server IP address, because it's this code, this TCP client.cpp can run on different machine, right? Like in a different Windows machine, Mac machine, whatever. Even in your Android mobile, or even inside your iOS mobile. Okay, iOS phone. So let's finish this thing. Server address dot scene address as last time, but here we need to we need to put this as host. Okay, we converted this host address to host network byte order. We need to now put it in here. Okay, so how we will do it? Very simple. Pointer means the value of struct in address pointer host HADDR. Okay, okay. So this HADDR because basically has the network byte order of this one. Okay, here, and we have put this one on the server address sock address in structure now. So your server address structure is populated, and you have your own socket here, client socket. Um, Now we want to connect. Let's do the connect. Okay, so this connect API will see here on the TCP server. Or did you created a socket, then you bind the socket to the specific IP address, and then you listen. Okay, so you binded it, you listen on it after binding, and then you are waiting on accept to accept the connection. Okay, so for server there are like four steps. First, creation of socket. Second, server address binding with the socket, because socket or server address are different, right? So you need to bind them together, and then you listen on the socket for the specific number of connection, and then there is the SF function where you basically receive the connection. And the client side you have basically three things. Okay, first you have the socket, second you have the server, and third is basically you connect to the server. You first need the socket. As I said, socket is the basic, and then you need the server address. So how we'll put the server address? Very simple. Struct sock address. It is sock address. Okay, because those function basically takes sock address, but you need to use the sock address underscore in. Okay, to put the value. Okay, and then the size of struct sock address. Okay, so with this you will connect. Upon successful connect, okay, you will receive. So to receive the data, I will create a while function, but I'll do it later on. First of all, only connect is enough for us. Okay, let's build this G++. Sorry, so this one is client TCP client. TCP, I don't know why, but looks like I failed to save it here. Oh, it is here. Okay, TCP client. Okay, G++ minus O client TCP client.cpp. So I build it. That is an error. Oh, sorry, I forgot to put server address. Okay, and they cannot find the guest host name by address. Well, we'll see. Sorry. Then I need to put the reference also. Let's see. Okay, so the only error I have this get host by name. So this is failing to find it. I'll figure out where the get host by name. Get host by name should be available in netdb.h. Hopefully, hash include netdb.h. Alright. Hopefully, I'm not sure, but let's see. Yes, so it's available on the netdb.h. Alright. So what we'll do, we'll need to run. We need to open two terminal. Okay, so we'll either do split terminal. Okay, let's do split terminal. So here, okay, we do two terminal. Here we'll run the server. Okay, let's run the server. Okay, so server is running on 5000. Here we run the client. Okay, so it generated a crash, I think. Oh, I know why. Because it did connect and then it's moved, right? It didn't wait. So we need to create a while loop. While one sleep. Let's say one. Okay. So yeah, I need to write down client TCP client. Okay. Then write down client. So it is waiting and it's trying to connect. I hope. Probably it failed. Well, we'll check why it failed. Alright, here let me print some log server sock listening on port 5000 bind, so you can check the bind return int ret equals to then print here print f here bind returns percentage d ret. Okay, so binding what binding returns if there's any error or whatever, and listen to server sock, and then there is a while loop client socket waiting on accept. If it is successful, then we'll basically write down it's successful, right? So let's check. Okay, so now let's run server. Okay, bind returns 0. 0 means okay, so bind is okay. All right, and it's basically listening on in address any. Okay, and I'll check what's my IP address is here. Let's write down if config. So probably I don't know what my IP address is, right? Damn, they're so bad. Then IPv6 address. I should have IPv4, so it's this is host number, okay, 70.198, 70.198. All right, good, not a big deal. 70.198. So I put here, okay, all right, here, okay, and then I build it, and then I connect it. So still it cannot connect. Okay, it failed to connect. Okay, no worry. Host socket connect int rate equals to here printf, we print client connected with percentage d comma rate. Okay, so let's build it, run it. Okay, so dot slash client socket trying to connect, and it's basically stuck here. Okay, um yes, fantastic. So you can see I'm connected to the server, and here I'm waiting to accept. It says so here. Let me clean it up. Okay, so the server. So here the server is running, right? Here, oh, you see. Okay, so it's bind failed. Bind failed. Minus. Give it a try, and then run it again. Okay, so the binding is failing. And the why is binding the failing? Because we closed it abruptly. Okay, so if you close it abruptly, then this will happen. All right. So I build it again, clean it up. Okay, so now it's working. And then here we go. I write connect my client. So here, so it's basically connected. Okay, so you can see the IP and you can see the port. This is the client port, where the client in which port user is connected. Now I will do what I will do. I'll send a hello from server side. Okay, so let's send a hello from server side to the client. All right, let's do it. Mm, to send it TCP is very simple. Send then the client socket, because we are sending it to the client, and then the send data. Let's say 1 2 3 4. hello, okay, and then hello client, okay, and here write down the length. This is like count 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, I done 13 length and 0 is a non-blocking. Okay. On the client side, uh, what we need to do from the client side, we need to receive. Okay, to receive, we have this while loop, right? So on the while loop, what we will do, RECB to receive API, and then the socket is basically the client socket where we are connected, and then the receive data RECB, comma maximum receive is like 1224 and 0. Okay, and here we'll print f, and here int receive equals to, here you need to terminate it, receive equals to receive percentage s, comma rcb. So we build it. There's a warning and there is an error. What I missed. So on the int is not a functional function. So RECB receive, sorry here probably, oh sorry here I cannot use this one, receive, okay, receive. Alright, so I messed it up. I build it. Okay, so it's built it, there is a warning. Okay, so for now let's just forget about it. Here it should be wrong, character. Okay, now, okay, so we'll run it. Server is running. Now I'll run the client. Okay, so I received. I am waiting. Here you can see received hello client. Server send it. Here the server sent hello client and server received. Okay, you can see. So now we can also do very interesting thing. I'll show you what you can do really. Here upon creating a connection, you can continuously send while one. Oh, yeah. Okay. Um. So what we'll do? I'll do a gets. There you go. Gets of SMD. Okay. SMD. Whatever I receive. And I basically send. Okay. SMD. Alright. So what I did a get and then I send. And here when I send, I should, what should I do? Do an strlen of strlen of SMD. Okay. So what I'll do, I'll take it from the console and then I will just send it. I'll see does it work or not. Here it will just, the client will just receive it. Okay, there you go. Let me build it. So now let's run the client server. I run the server. Now what I do, I run the client. Okay, so here I will write down hello. Let's see, it receives hello. I am server. There you can see it receives I am server. How are you? It receives how are you? Okay, so that's how you make TCP client server. Now, if you take this TCP client code in a different PC or like in a different mobile phone, but you're on the same Wi-Fi network, you can basically connect with the server if the server is running in a different machine and you can chat. So that's how you do it. Okay guys, so today that's it. I will commit the code in a GitHub repo and every one of you guys can uh, take this code and then use those code with my video and try to get a decent idea how to do network programming. So again, this is a very basic simple thing, and welcome to the world of network programming. So bye bye, take care, and please make sure to like and subscribe so that I can continue publishing such kind of network programming video.